Hello everybody, today we are going to study a new lesson which is radioactivity. This lesson is the second lesson in the unit of atomic physics. Also, this lesson is the last lesson in our semester. By the end of this lesson, you will know the meaning of radioactive decay, its types and its applications, measuring and detecting of ionizing radiation. Finally, precautions when radioactive materials are handled, used and stored. Please concentrate with me because this lesson is very important. Radioactive decay, also known as nuclear decay, radioactivity or nuclear disintegration. Radioactive decay defined as the process by which an unstable atomic nucleus loses energy by radiation. So atoms may be stable or unstable. Unstable atom loses energy by radiation. There are three common types of decay, which are alpha decay, beta decay and gamma decay, all of which involve emitting one or more particles or photons. First type of decay, which is alpha decay or alpha radiation. Alpha radiation is the atom of helium, which has 2 protons and 2 neutrons. Alpha radiation is a stream of alpha particles, which are positively charged. So the charge of alpha particle is positive charge. Alpha particles are large, which mean they can't easily pass through materials like clothes and paper. They also have the greatest ionizing effect because of its charge. When alpha particles are released into an electrical field or magnetic field, it will deflect toward the negative pole. Because it has positive charge, it will deflect toward negative pole. Alpha particles have a huge mass and so travel slowly. This means that it has more effect on the atoms and cause of ionization. The second type of decay is beta radiation. Beta radiation is an electron which has atomic number equal -1, mass number equal 0. Beta radiation is a stream of beta particles. Beta particles are negatively charged. These particles can more easily penetrate materials. They can even penetrate our skin, hair and thus body cells. But they blocked with denser materials like aluminum. Beta particles have lesser ionizing effect than alpha particles. When beta particles are released into an electrical field or magnetic field, beta particles will deflect towards the positive pole because beta particles are negatively charged. They will deflect towards the positive pole. Beta particles are lighter than alpha particles, so they move faster and so have lesser ionizing effect. Third type of decay, which is gamma radiation. Gamma radiation is energy, high frequency electromagnetic radiation. Gamma rays have no charge, also have no mass, but have a lot of energy. More energy than even visible light or X-ray. So gamma radiation has energy more than visible light or X-ray. Have no mass, also have no charge. Because of this, they are able to pass through most materials, but they can't penetrate a very dense materials like lead. When gamma rays are released into an electrical field or magnetic field, gamma rays will not deflect because Gamma rays have no charge. Gamma rays have very less ionizing effect because they are uncharged and are very fast. This figure illustrates deflection of alpha, beta, and gamma radiation. Alpha rays. When alpha rays released into or released between electrical field, they will deflect toward negative poles. We knew before that alpha rays are positively charged particles, so they will deflect toward negative pole. But beta rays, when beta rays released into an electrical field, they will deflect toward positive pole because beta rays are negatively charged particles. In case of gamma rays will not deflect because gamma rays have no charge. This figure indicates the penetration of alpha, beta, and gamma radiation. As we see, alpha radiation stop in a sheet of paper because we know before that alpha radiation have large mass, so it moves slowly. It stop in a sheet of paper. But beta radiation can penetrate paper and stop in a sheet of aluminum because its mass less than the mass of alpha, so it moves faster than alpha particles. Gamma radiation, it is energy, have no mass, have no charge, so it can move faster than beta, also move faster than alpha. So this type of radiation penetrate paper, aluminum sheet, but it blocked in a dense material like lead. This table shows some features of alpha, beta, and gamma radiation. As we see, firstly we see the symbol of alpha, beta, and gamma. Mass of alpha, which is 4 atomic mass unit, mass of beta, which equal 1/2000 atomic mass unit. But gamma, as we know before, have no mass, it energy only. Penetrating power of alpha very low, it can stop in a sheet of paper. Penetrating power of beta medium, but penetrating power of gamma is very high. Ionizing power of alpha very high, ionizing power of beta medium, but ionizing power of gamma very low because it depends on the charge. Also it indicates that alpha particles stop in skin or paper sheet, but beta stop in aluminum sheet. Gamma radiation stop in 2 inches thickness lead. Applications of radioactivity. Radioactivity have many applications in various fields, same in medicine, science, and industry. In medicine, radioactivity used in diagnosis and therapy. In science, it used to determine the ages of various rocks and rock formations and thereby quantify the geologic time scale. In industry, radioactivity used to measure the thickness or density of metal and plastic sheets, to stimulate the cross-linking of polymers, also used to induce the mutations in plants in order to develop hardier species, and to preserve certain kinds of foods by killing microorganisms that causes spoilage. To detect and measure ionizing radiation, we will use Geiger counter. Geiger counter is widely used in applications such as radiation dosimeter, radiological protection, experimental physics, and the nuclear industry. A Geiger counter can detect ionizing radiation such as alpha particles, beta particles, and gamma rays using the ionizing effect produced in Geiger-Muller tube. Radioactive decay. We have 3 types of decay: alpha decay, beta decay, and gamma decay. Alpha decay or alpha particle is helium atom that has atomic number equal to and mass number equal 4. So during decay or during alpha decay, the atomic number drops by 2 and mass number drops by 4. During alpha decay, atomic number drops by 2 and mass number drops by 4. As we see in first equation, uranium has atomic number equal 92 and mass number equal 238. When uranium decay by releasing alpha particle, the new atom has atomic number equal 90 and mass number equal 234, because the atomic number will drops by 2 and mass number will drop by 4. Also, the atomic number on left side should equal the atomic number on right side. On left side, uranium has atomic number equal 92. On right side, the atomic number of helium and the new atom is 2 plus 90 equal 92. Also, mass number on left side should equal mass number on right side. Mass number of uranium equal 238 and the atomic number on right side equal 4 plus 234 equal 238. Second example is thorium atom has atomic number 90 and mass number equal 234. During decay, it will release helium atom or alpha particles, and the new atom has atomic number drops by 2, mass number drops by 4. As we see, the new atom has atomic number equal 88 and mass number equal 230. Atomic number decrease by 2 and mass number decrease by 4. Also, atomic number on right side equal 2 plus 88 equal 90, same on left side. Mass number on right side equal 4, 230 equal 234, same on left side. Second type of decay is beta decay. Beta particle is an electron. The atomic number of electron equal -1, mass number of electron equal 0. So the resulted atom cause atomic number increase by 1 and mass number does not change. The resulted atom has atomic number increase by 1 and mass number does not change. This example shows the decay of thorium by releasing beta particle. Thorium has 90 atomic number and 234 mass number. When it releases beta decay, the new atom has atomic number equal 91. So atomic number increase by 1. Mass number does not change, 234, same thorium atom. This in case of beta decay. In case of gamma decay, gamma radiation are generally not shown. The atomic number still same and mass number also still same, because gamma radiation have no charge. So during decay by releasing gamma radiation, the atomic number and mass number will not change. This figure illustrates the types of decay: alpha decay, beta decay, and gamma emission. Firstly, alpha decay. Alpha decay is releasing alpha particle which has 2 atomic number and 4 mass number. So a new atomic number drops by 2 and mass number drops by 4. The new atom has atomic number drops by 2 and mass number drops by 4, as we see. Beta decay. Beta decay release electrons. So the new atom has atomic number increased by 1. See the new atom, which is X dash, its atomic number increased by 1, but mass number does not change, same. In case of gamma emission has no charge, so atomic number, mass number still same, does not change. This for gamma, beta, alpha decay. Half-life time. Half-life time is the time atom takes for half of the unstable nuclei in a sample to decay, or for the activity of the sample to halve. This curve shows how radioactivity sample is decaying over time. We have this graph as a relation between activity and time. At time 0, the activity equal 80 picocurie. When the activity halved, it will reach to 40 picocurie. The time needed to activity to reach 40 picocurie, it will equal 2 days. Also, if the activity halved from 40 to 20, it needs other 2 days, so it will be 4 days. From the start of timing, it takes 2 days for the count to halve from 80 down to 40. It takes another 2 days for the count rate to halve again from 40 to 20. Half-life time ranging between seconds to thousands of years. Same in carbon-14. The half-life time of carbon-14 equal 5,700 years. Half-life time of carbon-14 equal 5,714. So half-life time not constant, it ranging from seconds to thousands of years. Effects of ionizing radiations on living things. Ionizing radiations affects on the cell of our body. It may damage the cells, but cell will repair itself. It may affect the cell's ability to reproduce itself correctly. Also may causing mutation or may kill the cell. If you remember Hiroshima and Nagasaki, during the Second World War, 2 atomic bombs were dropped on Hiroshima and Nagasaki in Japan. Those people who survived the blast were exposed to a large dose of radiation. Such doses caused severe damage to cells all over the body, especially in the skin, blood, bone, tissue, and gut. Many of these people died within a few weeks. Those people who were exposed to a small dose recovered from such immediate effects. So, the ionizing radiation has hard effect on living things. Precautions when radioactive materials are handled, used, and stored. We know before that ionizing radiations have hard damage on our bodies, so we should save some precautions that help us to protect our bodies. Firstly, don't eat, drink, or perform other hand-to-mouth procedures like licking stamps, applying makeup in any room or lab which has been posted caution radioactive materials. After that, don't bring personal belongings into the radioactive work areas of the lab. Also avoid wearing rings, watches and similar items during work. Don't work with radioactive materials if you have an open cut or wound. Immediately after use or work with radioactive materials, wash hands, then monitor them thoroughly. Monitor hands and clothing, especially before leaving the lab. Don't store food or drink containers in the same location as radioactive materials. Finally, workers should be thoroughly familiar with the properties of radioactive nuclei they are using. Now we are going to solve some questions related to this lesson. Firstly, complete the following nuclear reaction by filling in the missing particles. We have Rn with 86 atomic number and 210 mass number. This atom will decay and release alpha atom with 2 atomic number and 4 mass number. What is the new atom? What about the atomic number and mass number of a new atom? When an atom gives off an alpha particles, its atomic number drops by 2 and its mass number drops by 4. So the new atom has atomic number 84 because atomic number drops by 2 and mass number equal 206 because it will drop by 4. So the new atom is PO84206. If you don't know the symbol of new atom, you can write X instead of this atom. Second question, write each of the following nuclear reaction. We want to write the nuclear reaction. Carbon 14 used in carbon dating decays by beta emission. So we have carbon atom carbon 14. Beta particles have the symbol of E, -1 atomic number and 0 mass number. Emitting beta particle causes the atomic number to increase by 1 and mass number not change. So carbon 14(6) will release beta, so the new atom will be X714. Atomic number will increase by 1 and mass number does not change. After that, uranium 238 decays by alpha emission. Alpha particles have the symbol of He24. So emitting an alpha particle causes the atomic number to decrease by 2 and mass number to decrease by 4. So uranium 238 mass number and 92 atomic number will release alpha particles, and the new atom will have or will has 90 atomic number and 234 mass number, because atomic number will decrease by 2 and mass number will decrease by 4. This is the end of our lesson. Hope to study well and try to solve the homework that uploaded on Moodle. Thank you, my students.